Okay. All right, welcome everybody. I think we'll maybe wait like 1 or 2 more minutes and then we'll go ahead and get started with our introduction to R today. How is everybody doing today? You could pick an emoji to put in the chat if you would like to share how you're doing today. Or go off mute, whichever you prefer. All right, awesome. Okay, I think I'm gonna go ahead and share my slides. Maybe. Okay, hopefully I'm sharing the right.
Your display is swapped, Alyssa.
Oh no. That was weird. Okay, hold on. Let's stop that and try again. I love it when technology works well. So great.
Yes.
All right, let's try that again. Maybe. Of course, now I've lost my Zoom. That's cool. All right, did it work this time?
Yes.
Excellent. You just gotta do it in the exact perfect right order. Okay. Also have my chat up so I can see everybody. Okay, excellent. So welcome to our second workshop that is part of the Fair Forward program. So today and Wednesday, we will be doing sort of a two-part workshop. We've got an introduction to programming in R. Today, like I said, is our part one, and on Wednesday will be our part two. Same time, same Zoom. As I mentioned, this is part of a series, right? So we already did our open source data introduction. This week is going to be our introduction to coding in R. And then we will also this month have a basics of version control introduction. And then next month we will do our data visualization. And then finally we will have our hackathon on the 1st and 2nd November. So just as a reminder, this program is Fair Forward. And it's all about getting hands-on experience for participants in analyzing open source scientific and healthcare data, really trying to get everybody, real hands-on, real-world problems to tackle and understanding more about open source science and data. And hopefully through this process, you'll learn more about how to apply the FAIR principles. So that's findable, accessible, interoperable, and reusable. We actually went through these a lot in our last workshop. And this program is specifically prioritizing BIPOC students from HBCUs, HSIs, TCUs, and MSIs. Yeah, so that's a little more about this program. So yeah, all about open source data science learning materials. We've got these 5 preparatory workshops, and then we've got our virtual hackathon. All right, so that's sort of the program in a nutshell, just to remind everybody. So like I said, today is all about all things R. So just a real brief introduction to what is R. So R is a programming language and an environment for statistical computing and graphics. It was actually first created in 1991. It's actually built off another programming language called S. This programming language was actually closed. It was not free. It was not open source, but it was specifically built for statistics. And so people really loved it. They thought there was a lot of strengths in it, but they didn't really like that it wasn't open and it wasn't free. So basically they kind of took everything they liked about S and then like rebuilt it in R. So basically like S, R is really built for manipulating data, visualizing data, and performing statistics. So it really has its strengths in those kinds of processes. And the great thing about R is it is open source and open development. So it is open, free to download, free to use, and it's free for you to continue to develop on it, write your own software that works with R. If you did want to use this on your local machine, you could go to the rproject.org and you could install R on your local computer. So like I said, the things I really love about R is, they're free. It's free, open source. It's a high-level language. It's very powerful, very flexible. It has tons and tons of add-on software or packages. And the other thing I love actually the most about R is it has a really strong community. There's a whole conference. Actually, there's multiple conferences on all things R across the community. So you can go to an R conference and you'll see everything from healthcare to sports data and everything in between. There's a great community online where you can post things on message boards and people are really helpful in supporting your journey. Now, sort of sitting on top of R is RStudio. So this is an integrated development environment, or an IDE for short. Basically, this is just kind of a fancy way of saying that there is some software that interprets R, helps you write code, helps you view the output of your code, helps you find errors to the best of its ability, helps you manage your file. It has a bunch of interactive tools, and you can also view all sort of like help documentation. So it's meant to sort of be all the things you need in one place. And just as a heads up, you may also see, instead of RStudio, Posit, and that's because they've sort of changed their name in the last couple of years to indicate that RStudio isn't just useful for R, you can also use it for other programming languages as well, such as Python. But yeah, really the idea is this is software that is meant to help you in your coding journey and make things much more simple, easy to use, easy to find. This is something that you would install separately. You can actually go to posit.co, downloads, and then install the RStudio IDE. Now, we're not actually going to ask you to install a bunch of stuff. That's really, really tricky, especially in a virtual setting. We can sort of send you a bunch of instructions ahead of time, but usually that doesn't really go super well. So instead, I like to use something called Posit Cloud. So basically, this is a web browser version of RStudio. It's a platform that lets you use RStudio in any browser. So technically you could even do this on a Amazon Fire. That's like a $50 tablet. I actually did test this. It doesn't look great, but in theory you can, do really awesome data science with a really cheap tablet because it's all browser based. I really liked this as well because then, like I said, you don't have to download any software. Especially if you only have a Chromebook, then you can't download software. So having this ability to use it just in your browser is really useful. So I really love it for teaching, but I also really love it for research collaboration, because the really nice thing about this is basically you can build like a whole project in Posit Cloud, which has your data, your code notebooks, your Word docs, like basically everything you need for a particular project. And then all you have to do is share a link and they get the entire environment, right? All the tools you've downloaded, all the things you've run, like all with just a link, instead of having to constantly like email back and forth, like all these separate things. So it's really, really great for collaboration as well. The other nice thing about this is Posit Cloud has a free tier. There are like pay tiers, and while we're doing the hands-on workshops, you will be using my pay tier just because it makes things a little bit easier for us to like help you if you get stuck and things like that. But yeah, the free tier is there. It's free forever. Once you're done in the workshop, you'll be able to still work on your things in the free tier. And I believe it's back up to 30 hours free each month to work in Posit Cloud. Now that doesn't mean that you can't access stuff once you hit that limit. It just means that you can no longer like run new stuff. I will say, you know, one way that you can work within these bounds is if you have another email address, you can create another account and then you can share the link with that account and then you can keep going and get another set of hours. So yeah, we will be going to Posit Cloud to make these accounts together. So today's focus, well, today and Wednesday's focus is really going to be about data manipulation. The visualization will obviously come in the next set. So today we're going to go through a tour of RStudio. We're going to talk a little bit about coding notebooks, so R notebooks. We'll introduce you to the data set that we're going to use in the next couple days. We'll also run through some basic R commands, understanding R packages, how to import data, how to deal with different variable types, and then write data into files. And then most of Wednesday will really be like more complex data manipulation. Okay, any questions on our whirlwind tour of what we're gonna do today before we actually create our accounts? All right, I don't see anything in the chat. Okay. So let's go ahead. Oops, nope, that's not what I want to do. There we go. Excellent. Oh, I should have just shared my whole screen because I'm going to need to get to the browser. Yes, you'll be using, basically, Posit Cloud is exactly like RStudio. It's just in a browser instead of on your local machine. All the stuff that we do in Posit Cloud, you could also do on your local machine if you went and installed R and RStudio on your local machine. But yeah, so they pretty much function exactly the same. It's just one is using somebody else's computer instead of yours, basically. But all the same things will apply. Hopefully that answer makes sense. And now I've lost my sharing option. That's fun. Oh, there we go. Okay. Hopefully you're now seeing my Posit Cloud screen, I hope. Excellent. Okay, cool. All right, so everybody's gonna wanna go, if you already have a Posit account, by the way, you don't need to make a new one. So if you do already happen to have a Posit account, sit tight, but I imagine most of you do not. So please go ahead and go to posit.cloud. Once you're at posit.cloud, you can create a new account. Sort of down here, there's a giant button that says Get Started. There's also over here in the corner a sign up button. These two do the same thing. So let's go ahead and click on Get Started. And I'm just gonna pause here for a second and make sure everybody is here. All right, once you've hit the Get Started, it actually brings you to this plan situation. Because like I said, there are both free and non-free tiers. We're gonna have you sign up for the free tier account for today, because then I'm going to share with you like my paid workspace. So as I mentioned, this is the free tier. You get 25 hours per month, 25 projects per month. And like I said, if you go past that, you can still open all your projects and things like that. You just can't like run new things. So we're gonna go ahead and click on the like Learn More tab under the Cloud Free option. And then it sort of further breaks down like the stuff that you get with the free tier. Great, awesome, fantastic. Go ahead and click sign up. Now there are basically a couple of different ways you can sign up. If you want to use a university email address, you could go ahead and do that, or anything other than like a Google email address, you could just kind of use your email address. Otherwise, if you have a Google account, you can sign up with Google. If you have a GitHub account, you can sign up with GitHub. And if you have a Clever account, you can sign up with Clever. I personally would recommend using a personal account versus a school account, partially because your personal account stays with you forever, versus your school account will eventually not be with you. And even if you created an account with the school account, then you'll have to remember to like swap that to a personal email before you leave, because it will periodically kind of like email your email address and be like, hey, is this you? Are you there? So do make sure that you, or at least I recommend to create an account with a personal email if you want to kind of like continue to use this past your school days. But it's kind of up to you which one you pick. So go ahead and choose your sign up adventure, and it will send an email if you use your email sign in. If you sign up with Google, like that's it. You just click sign up and it's going to basically talk to Google and authenticate that way, and everything's just good. If you do sign up with an email address, it will send an email to that email address, which you will have to click accept first, and then you can log in. So I'm going to give 2 minutes for folks to go ahead and create their accounts. Does anybody have any questions on what we're doing? Okay, then I will be quiet so everyone can sign up.
Maybe once you've signed up or logged in, you want to drop a little thumbs up on the chat so we know once everyone's in. That'd be great.
That's a good point. Actually, no, can you do the raise hand thing? Because then I can just look at the participant
Oh, yeah.
list and yeah, so when you've made your account, go ahead and raise your hand, because that one will stay. And then I can quickly see who's all done it. Excellent. All right, we're just gonna give it one more minute. We're almost all there. All right, everybody Anybody stuck?
Yes, sorry, I just had a little hitch. So, where we have the plants, which one did you say we should select again?
Well, it entirely depends on you. Like I said, you can either pick an email and then create an account with just like literally any email address, but then you have to remember it's going to send you an email you'll need to confirm. Or you can sign up with Google. Like if you already have like a Gmail, you can just authenticate with that Gmail account. It's completely up to you.
Okay, okay, that's
The Gmail one's faster, but no preference really. Okay, so once you've created your account, you may need to then like log in again. So then you just have to remember what your login account is, whether it was the email address that you put in or you picked the Google account is probably the second most common choice. So you'll have to click login. And I have made an account specifically for this. It's just our studio test. You're gonna enter in your password, unless you're already signed in. All right, and it should look more or less like this your first time logging in. So I'm gonna pause again, make sure everybody's logged in. If anybody does not see this window when they log in or something to this effect, please let me know. Once we're all here and logged in, I can give you the link for the actual workshop space, which I guess I can do that now. So once you're logged in, you can go ahead and either copy and paste this into like your browser or just click it. It should work if you're logged in, but you have to be logged in for that link to work. Once you're logged in, if you paste that link that I just put in the chat in there, it should be like, hey, there's a cool space. Would you like to join it? And you can click yes, but I'm gonna pause here to make sure everybody is here. Once you've joined the space, go ahead and raise your hand again so I know everybody's in the space. All right, I'm gonna go, since it looks like almost everybody is there, I'm gonna go ahead and click yes. And it may look like just kind of this blank welcome, and you may need to like click on the little Fair Forward workspace to actually see stuff. Now, granted, you may not have this sidebar. If you don't, that's okay. If it looks more like this, sometimes it doesn't pop up automatically. You just wanna go over to the left-hand corner here, click these open navigation sidebar, and then you'll see our workspace, the Fair Forward workspace. If you click on that, you should now see the content for our workshop. All right, I'm gonna pause here for a second. Anybody need help or not see the shared workspace? Okay, while we're here, I am gonna just describe a couple of things. So as I mentioned, there's this sort of sidebar navigation. And so anytime you are kind of doing work in your free tier space, it'll be your own workspace. Right now, there's nothing in there because we've not done anything. But as you sort of like create your own content, that would show up here. Any shared spaces will also show up here. Like you see, it's got like the little 3 peoples. That's because this is a shared workspace. And anything that I've created for the content here would show up here. A couple other things. So there are some learning tools in Posit Cloud. There's a guide. There's also sort of like what's coming up, what's new. There's also these recipes. So recipes are kind of neat. They basically describe like a very small bite-sized problem with real data and then give you an example of code on how to like do that particular thing. So a recipe could be like, I would like to look at a bar graph of the count of students in a class or something, and then it'll actually show you data and then show you like real code for doing that thing. So recipes are kind of like these nice like little snapshot applications of code. And then cheat sheets are basically one-pagers that describe some of the more common packages in Posit Cloud. I'm actually just going to click on this real quick just to sort of highlight. So there are a bunch of different packages in R, and some of them do have like little cheat sheets. And so if I click on one of these, for instance, I'm going to click on, I know we're not doing visualization today, but it is the most visual plots. So it's like the nicest one to show. But basically, you get like these little one-pagers that visually show you sort of like a bunch of different functions and like, oh, if you want this graph, you can look at this. If you want this graph, you can look at this. But it also has this like interactive book, I guess, as well. Yeah, let's call it that. But yeah, so like this is kind of, I will say the cheat sheets, you do kind of have to at least know where you're trying to go or what you're trying to do in order for the cheat sheets to be helpful. They don't necessarily break down how to use the code. They're basically just like, if you want to do this, this is the function you use to do it. So they're great for referring back to. Many packages have lots and lots of functions. And there might be functions that you use like very rarely. So like even I still use the cheat sheets to kind of refer back to things. So yeah, those are the cheat sheets. So again, like these are all potential things that can kind of help further support like your learning when you're first starting out. I also want to point out the Posit community. This is actually basically a message board. So if you have any technical problems with either like not just Posit Cloud itself, but just like coding problems, right? You can post like, I get this error message, I don't know what it is. I can't get into my account. I want to code this thing, right? I want to read these CSV files and I can't figure out how to do that. And people will come and answer your questions. So it's a really great community. And again, if you get kind of stuck and you don't know where to go, this can be a great place to just throw up a question and see if other people can answer it. Also, it's a great place to search. Like you can search here first and be like, I got stuck on this, and see if somebody else already got stuck and potentially have the solution there. So just want to point out that the Posit community is great for that. All right, so those are sort of some of the handy tools here on the side. So now I'm going to close that out. Any questions on that? I should also, if you click on your name, you will also see like how much time you've used so far in each month. Okay. No, the cheat sheets are open. Actually, if you just go to like, you don't even have to log in. If you just go to like Posit Cloud cheat sheets, like you don't even have to like log into RStudio to get those. Those are free and open, and you can find them here. So if you just like go to posit.co resources cheat sheets, you'll also find them here. So yeah, they're free and open. See, you can click on them even outside of Posit. So very handy. Good question. All right, excellent. Any other questions? Okay, so then let's go ahead and click on our project, the Introduction to R Programming. Should have a little like, if you've not clicked it yet, it'll have start. If you've already clicked it, it'll say continue. So go ahead and click it, and it will basically make a duplicate just for you. As long as I set it up correctly. All right, once you're in the project, again, if you could just like pop your hand up so I know everybody's here and it's copied and we're all good. Sometimes it's a little bit slower for some people versus others, and I don't want to rush.
I'm sorry, Alyssa, to make you repeat, I got lost.
Yeah,
My
no
bad.
worries.
What
Yeah,
was
please.
that?
So if you are sort of all the way back here, you can always head to your navigation bar, click on Fair Forward, and then all you have to do is click on the Introduction to Programming. When you click on that, it should create a copy for you. Did you find it?
I did, thank you.
Excellent. Yeah, no, please stop me if you get stuck or I went too fast. Okay, excellent. I think I see everybody's hands up. Yes, yes, yes. Okay, cool. Okay, so here we are in our project. So you can kind of think of like our projects as sort of like, you know, these are the literally separate projects, right? So for every project, it's going to be like its own unit, its own question, its own thing that you're trying to study. And so we've got in our project here, we've got sort of like this main left-hand window is the console. You can kind of think of this as like the R brain. It's what's going to run like code commands here on the console. Granted, we're not actually going to submit our code in the console. We're actually going to write and submit all our code in the notebook. But the notebook will actually still push to the console in the background, and it'll be like running things. So like I said, you can kind of think of the console as like the R brain. On this on the right-hand side, there's these two windows, which by the way, you can definitely adjust how big or how small you want these windows to be, depending on your comfort. You can also rearrange these completely if you really wanted to. If you go to, I never remember this because I very rarely tweak this. I think it's in the
Under global options.
What I thought. I was about to say global options. So you could sort of like change which way around these windows are. You can even add different windows. I typically keep it this way because originally you couldn't change this, and so I just got used to it. That's how old I am. I'm R years old. Okay, so you can adjust these as you like. On the right-hand upper panel, there's actually a couple different tabs here. You have the environment tab. So as you create objects, they'll show up in the environment, and we'll see that as we go. There's also the history. So as you run code, that already run code will show up here in your history. You can also connect like other applications to R. So for instance, GitHub is a pretty commonly used tool that we use in bioinformatics and other coding activities. And it's nice for version control and things like that. So you can actually directly connect GitHub to RStudio, and you can actually have them like talk to each other instead of having to like use the two applications separately. The other thing I want to point out is there is also like a little interactive Learn R tutorial. So if you did want to kind of just practice doing more R coding, you can also do that here. It'll give you little prompts and then you put in code and it'll be like, yay, that's right, or it's not. So if you just want to kind of practice more code, that could be a place to do it. Then you have this lower panel. This is showing you the files that are in the cloud. And I do want to specify that. So like if you were doing this on your local machine, the one difference would be that you actually see all the files on your local computer. But because we are in the cloud, we only see files that I've like explicitly pushed into the cloud. So we have our 2 notebooks that we're going to use today and Wednesday. I also have the slides. So the slides that I have presented already, and then some that we'll use on Wednesday, all of that's here. There's also some images that are going to pop up in the notebooks. And then this rproj file that basically kind of like keeps the architecture of all of this together. Then you've got your plots tab. If we were running code on the console, it would show up in the plots tab, but we're actually going to run everything in our notebook, so plots will show up in the notebook. Then we have our packages tab. I'm going to talk a little bit more about what those are, but suffice to say, they show up in our packages tab and we can, install things and see them and load them here. You also have a help tab. So, if you ever are stuck and you really want to pull up the documentation for a particular function or a particular package, you can type that here. I will say this help is not like Google help. You can't type in like a whole sentence of things. It's really meant to be like a keyword or a specific function, and it'll pull up the manual that will sort of like describe that function. If you need a little bit more verbose help, again, it might be worth popping over to some of these other resources, or like I said, the Posit community, and kind of throwing that up there in their message board. Then there's this viewer tab. If we were running more interactive graphics, and again, it wasn't in the notebook, it would show up here. And technically you can also run presentations from RStudio, but I've never done that because it's really messy. And it's much easier to just make a couple of slides in PowerPoint. All right, so that's sort of like the whirlwind tour of like what these windows are. Any questions on where things are? Oh, I will mention, so in the files tab, if you did want to upload more files, you would click this little upload button. And then eventually, if you want to download things, you can like select the things you want to download, and you click the cog and then export to download things, right? Because that's the one thing that's a little different than your local machine, is that it's sort of in this other computer. So if you want to grab things, you'd have to kind of do that extra step. All right, any questions on our whirlwind tour? Yes, Maya? Hopefully
Hi, it's Mia. I was just wondering, you mentioned notebook. Where would the notebook be on this program?
Yes, so that's actually the next thing I'm going to do. So we're going to work in the first notebook, so the 01 intro.rmd, so the R Markdown notebook. If you click on it, so everybody click on that file, and it will now open another window that is the actual notebook. Hopefully that answered your question.
Thank you.
Excellent. Okay. So yeah, once you click on the notebook file, it will actually open up in the upper left-hand panel. And like I said, we're going to run everything in the notebook, so we don't actually need the console. So if you go ahead and there's like a maximize and a minimize window in the like right-hand corner of the console, so you can go ahead and tuck that basically down here. Doesn't like disappear, it's just minimized down here at the bottom. So if you did need it again, you can pop that open again. Yes, I've got
What's the advantage of using the notebook versus the console? Like, what's the difference?
Yeah, so I'm going to go over that
Okay.
right now. Yeah, okay, cool. So one other thing I would like everybody to do is to go ahead and click the visual mode. So in the left-hand corner, there's like source and visual. If you go ahead and click visual mode, a little like pop-up's going to be like, hey, you want to activate this, and you say use visual mode. And then you see that our notebook actually looks like a Word doc now, right? So we've got text, we've got embedded images, we have links we can click, but there's also code. And if I click play on this code, I see the solution to said code. In this case, it happens to be a plot. So this is what is sort of the strength of a coding notebook, whether that's a Jupyter notebook in Python or an R notebook in R. The idea that it's this literate programming, right? This way that you can write things like you would in a Word doc, describe things, embed things, but you can also have your code chunks connected to your descriptions and also your output connected to your code and your descriptions. So that's what's really nice about all this. You know, I can write things here, I can modify them, I can edit them, I can edit my code, I can rerun it. If you were writing all of this on the console, like you couldn't do any of these things. Basically, you could sort of like write your code and you don't really save it either. Like when you run it in the console, like you run it, but there's nothing that really saves it anywhere and you can't make notes anywhere. I mean, I guess you could pull it from your history, but that would end up being like really big chaos. So really this is meant to be like reproducible coding. The fact that you can create this notebook, you can write and describe what you want to do. You can then show how you did it with your code and then what the results are. So hopefully that kind of helps answer the question of why we are doing code in our notebook instead of just like directly on the console. So reproducible, shareable, literate code. The other thing I'll mention is technically, while this looks like a Word doc, it is in R Markdown. But the really nice thing about the RStudio IDE is that technically, if you kind of go and look at the source, like this is the R Markdown language, right? Like this is how you sort of like would write, here's how I put a link or here's how I embed an image. The nice thing about the RStudio IDE is you don't actually have to know anything about R Markdown. The visual editor basically does it interactively for you. So for instance, if I want to bold this, I highlight it, go up to format and hit bold, and it bolds it for me. But if I go back to my source code, it's actually written what it should be in R Markdown for me. So the really nice thing about using the IDE is that it's going to sort of take care of a lot of the R Markdown for you. You can basically treat it like you would a Word doc. The other thing I'll mention is each of you has a copy of this entire project. So you are free to modify any of this however you like. I've tried to kind of be descriptive, but you're welcome to add any more things that you want in the description and the code. All right, any questions on our notebook? One other thing I will mention is, actually two things I'll mention about our notebooks is, so there's an outline over here on the corner that'll kind of jump you to any one of these sections within the notebook. But if you don't want to have that real estate eaten up by our outline, you can also minimize it. If you just click on the little outline button, it'll disappear. The second thing that I want to mention is our notebooks are renderable, and what that means is basically I can convert an R notebook into another file type. So there's this little button up here that literally looks like a ball of yarn, and it's called knit. And if I click on the drop down, I can actually convert this R Markdown document into an HTML, a PDF, a Word doc. And the nice thing about that is I can basically like do all my code, make my beautiful like Word documents and embed links and do all this stuff, and then knit it into an HTML doc, and then give that HTML doc to anybody, even like outside of R. They can just like open it in a browser and they can see all your code, see all the output, and not have to run a single line of any code, but they get to see everything. And they can kind of, if you have any interactive graphs, they can click on it, they can scroll through tables. So kind of rendering these into HTML docs makes them like super accessible for people even like outside of the R space. All right, any questions on coding notebooks? The other thing that's really nice is like, right, you can save this entire notebook and then share it with somebody else and they can, you know, build on it as well. So it's much more collaborative. Okay, so as I mentioned, you've got your sort of description, your Word doc part in this white space. Then in the gray chunk, this is your code chunk. And it actually tells you what kind of code is going to be in this chunk. In this case, it's an R code chunk. Then you have your actual code. And like I said, if you go ahead and click play, actually everybody go ahead and click play just to make sure it works. When you click play, you should see a graph that shows up. This happens to be, there's a cars data set that just like lives in R. And this is just plotting like I think like distance versus speed of different cars. This is mostly just to make sure it works and then everybody can run it and there's no weird visual glitches. So if anybody doesn't see this plot, please let me know so we can make sure you're good to go for the rest of the workshop. Okay, excellent. One other thing I want to draw your attention to is, I must admit this is not super easy to see because it's like kind of this grayish font color. But if you look at the top right corner of your plot, it has these 3 little icons here. One of them, it looks like kind of a window with an arrow. And so for instance, you know, if you're working on a small screen, like I've got a pretty big screen here, so my graph looks fine. But if I'm working on a smaller screen and it looks kind of like smashed up, I can click this button and it'll actually pop it into a new window, although, I'm not sharing my entire window, so maybe you don't see that. You know what, I'm just gonna stop sharing and reshare with my entire window. What could possibly go wrong? Let's do desktop 1. Oh wait, which one did I just share? Hopefully the right one. Are you looking at my posit?
Yes, we are.
Excellent, good. Just making 20 windows. Okay, excellent. Okay, so now I can actually show you what that pop-up will look like. So it'll pop it up and then you'll actually see it in a new window, like we're in a new tab here. And you saw like it even kind of like re-rendered it on the fly to make sure it like kind of the aspect ratios looks good. So then you can have it like in an entire full window. So that's kind of a handy thing. Like I said, it's this little pop-up option and it'll put it in a new window tab. Although if you've got pop-ups blocked, you may need to like allow it because sometimes it'll hit that. The other one here is expand or collapse. So like, let's say I did a printout and it was like massive table with like a bunch of lines and I didn't want to scroll through all of that to get to the bottom. I could just like tuck it in. So it's still there, like it's still run, it's still there. It's just basically minimizing it so I can get right to my next thing. The last option here is actually a clear output option. So if you click this button, it means it literally has deleted whatever you've run. So if I hit clear output, it doesn't exist anymore, right? So if I want to see that plot again, I gotta rerun the code chunk. Okay, any questions on sort of the output setup in a notebook? Okay. So for the hands-on today and Wednesday, we will actually be using real-world data. We're going to be using data from the CDC. It's the Youth Risk Behavioral Surveillance System, or the YRBSS. It's actually a whole bunch of different surveys that track behaviors that could lead to poor health in students grade 9 through 12. And the surveys are administered every other year. And they track a whole, or at least try to capture a whole ton of health-related behaviors and experiences. So that includes things like student demographics, so sex, sexual identity, race, ethnicity, grade, etc. There's also like behaviorals and conditions around, you know, injury and violence, bullying, diet, mental health. There's also specific questions on substance use behaviors like vaping, alcohol use, other drugs. And there's also survey questions around like general student experiences like parental monitoring, school connectedness, unstable housing, and the like. And like I said, this data set is from the CDC, so we're actually going to pull it directly from the CDC. We're not even going to like do anything super special or do any special cleaning. Like you can kind of pull it as is because they've annotated this data set. I really love the youth survey data, partially because it is real data, and yet it's like very usable data, very easy to navigate. It's just it's survey data. It's pretty well organized. So it's fairly straightforward to kind of jump into. In order to pull this data though from the CDC, we will actually need a special package to do that because it's actually in a particular data format. And so I do want to kind of discuss what R packages are because I've now used this word a couple of times. So R packages are really technically any kind of, you can have Python packages. Really, there's tons of different kind of packages, but the idea behind like a package is that it's a collection of our functions, documentation, and data for a very specific purpose, right? There are R packages for analyzing football sports data. There's packages for analyzing, RNA data. There's packages for analyzing customer churn data. Like there are packages for just about every like specific question that you might have in R. There will be a package that's like hopefully built to kind of help you answer that question. And like I said, it'll have a bunch of functions in it, a bunch of code, hopefully some good documentation, and preferably a little bit of like mini data, dummy data, toy data, some kind of small data set to kind of help you make sure that you understand that the package has been installed, that the functions at least run correctly on their data first, and then you can move into your data. They are saved in a directory called the library. So like in our packages tab, we see the system library. And you can kind of think about this or remember this in that like packages are kind of like manuals, right? They really are instructions to do a specific thing. And you might store manuals in a library. So that's how I try to remember it. And there's a couple of reasons why these packages are sort of like, they have the ability to be turned on and off. So like while I'm in the packages tab, you see like some packages have checkboxes next to them and some don't. That checkbox means that it's actually turned on, it's active, and the things inside it are easily usable. And the reason that like not all of these libraries are just like on all the time is for a couple different reasons. So first of all, I mentioned already in sort of my introduction of R is open source and freely available to build by anybody in the community. Which is great because it means we can all build what we need for our projects, for our communities, for the things we care about. But what that also means is, different people creating different things, and there's not really any checks on what we're calling things, how we're designing things, how they may work with other packages. So these things might end up clashing, right? If I build something that's for a specific version that requires a specific name, it may not play well with other packages that require slightly different things. And you can kind of think of it in a simple way. So for instance, I'm gonna write a package on football statistics because I really love fantasy football. So I want to like create my best fantasy football team. So I am gonna write a package and I'm gonna write a function that's called fstats for football statistics, and it's gonna expect like football data, and it's gonna do some statistics on those football data sets and go on its merry way. And then maybe Padma is an ecologist and she really, really loves frogs and she wants to study frog data. So she's gonna run around collecting all this information about frogs, and she's gonna make a package on analyzing frog information, and she's gonna create a function called fstats, which is gonna be about analyzing frog data, and it will expect frog data and it will calculate statistics on frog data. Now, if both of these things are on at the same time and they're both called fstats, that's going to be a problem. Granted, there is a workaround for this, but it's just, this is to kind of illustrate that like it very easily, you can end up having things that really clash when, there's not really any monitoring of any of these things. So to kind of help decrease those clashes, you only turn on the packages you need. Nothing else gets turned on. And that's fine because honestly, most projects really only use a small handful of packages. The other reason why these aren't all turned on at the get-go is there's over 20,000 packages in the CRAN repository, so that's a place where you can store R packages alone. And each one of these packages has, like I said, data and manuals and functions and code. And if every time I booted up R, it needed to load all 20,000 of those bits and bobs of data and code and documentation, it would take like hours to boot up. So better to just turn on the package you need, and then it takes like a minute to get all of that together, versus doing that for 20,000 packages where you're really only going to use like 4 or 5 of them. All right, so that's sort of the concept of packages, right? They're these like tidy, discrete pieces of software for a very specific purpose. They are not necessarily on until you actively turn them on. Any question about packages? Also, if you call it Ribbit, I feel like it should have like 3 R's though.
It should, you're right.
Okay, so as I mentioned, in order to read in the data from the CDC, the youth survey data, we're actually going to use a package called the ASC setup reader. And basically this will read in the I am so dyslexic, sorry, ASC data file and the SPSS syntax file. So basically like the CDC has these data sets that they've kind of pre-curated, and they are sort of like in this SPSS syntax. And obviously we are working in R, so we really need a package that's going to basically convert that syntax into one that R recognizes. And that's what this package is going to do. So I just want to mention here, like the first time we work with a new package, usually you need to install it by using the function install.packages and then the name of your package. However, in this case, as I mentioned, we've already pre-built this environment and we've done that for you. You can actually already see it right here. I just want to mention it because if you did end up, installing a local R version and you wanted to redo this on your local machine, you will need to install the packages that we've used in this workshop. As I mentioned though, we've already got it installed, so the only thing you have to do is basically turn it on or load it. And as I mentioned, these packages are stored in a place called a library. So actually the function to basically go and retrieve this particular manual is by basically going to the library and then grabbing the one you need. So if I want to turn on this package, I would say library. So that's the function that's basically like, go fetch this manual. And this is the manual I want you to fetch. So library, and then the name of our package should turn it on. So if you go ahead and click play on the library setup reader code chunk. Now nothing will happen because you're literally just saying like turn on the package. But you should see over in our packages tab that there should now be a checkbox next to our ACS setup. Calling packages are case sensitive, yes. So like if I said like setup reader with like a lowercase here, it'll give me an error and be like, there's no such package, this is lies. So it is case sensitive. So case sensitive means that lowercase and uppercase characters are literally treated like different characters. So an uppercase A is a completely different character than a lowercase a. That's a great question. Any other questions on our packages? I know that both the youth survey, but there's also the BERFIS, which is basically like an adult version of the survey, have like that they break down their demographic data, or at least for now, it's still broken down. But I don't know that they specifically like have like different like polls for that data, right? Like it's all in one aggregated file, and then you would filter it for like the specific you know, community you're interested in.
Yeah, that's correct. The data sets are not disaggregated.
No. They do have disaggregated for state. So the one we're pulling is for the entire country, but they are disaggregated by state. They're also like per year. So like I said, they do this every other year. So like you can grab 2023 separately from 2021 and so on and so forth. But yeah, they don't really disaggregate that data just because like it's relatively straightforward to be able to pull that once you have the entire aggregated set. In theory. Okay, excellent. So as I mentioned, we're going to go ahead and pull the data from the CDC. So this YRBS data is available in like these two different formats. You can either do the Access format or the ASCII format. And like I said, they also additionally have either SAS or SPSS linked files with it. And as I mentioned, we're not using SAS or SPSS, we're actually using R. So this package is going to help us pull that data. All right, so before we can actually create an object though, we need to kind of understand, or before we can import the data, we need to kind of understand how you actually create an object in R. So when we stream this data into R, we actually have to put it somewhere, and in this case, it's going to be an object. So what we want to do is actually take the YRBS object, or sorry, data, stream it from CDC, and put it in an R object. An R object basically contains information stored in R's temporary memory, and it'll show up here as we create them. And basically an R object could be a list, a table, a plot, basically any kind of information that you want to store as an R object can be stored. Once you've created this R object and you've stored it, you can retrieve it or manipulate it anytime you want by just like calling the name of the object again. So this process of storing an object is called assignment, and you actually use this little operator here, so the less than sign dash, to actually like give it a name and create the object. Now, before we can create an object, I do have to point out that there are a couple of general rules about object naming. So first of all, the first character can't be a number. You can have a number anywhere else inside the name, but it can't be the first character. So you can say frogs 5, but you can't say number 5 frogs. So it can't start with a number, but you could definitely say frogs with a 0 instead of an O because it's now in the middle of the name. So you just can't start with a number as your first character. It also can't contain spaces or special symbols. Sorry, let's just say special symbols. So things like the @ symbol, things like the hash symbol, you can't use these in names because like they already do other things in R. So they already have kind of a function, and if you tried to use them in naming, it would just get very confusing. So you can't do that. But you also can't use spaces because spaces sort of like help break down your function. And if you've got this white space, it would be very confusing. So if you do have a name that's more than one word, you can break up that word in one of two ways. You can either break up the two words by using an underscore. This is called snake case. So you see in the two words here, like snake and case are separated by this little underscore. Or you could separate your multiple words of your object by capital letters. So this is camel case. You got a capital C here for camel, the first word or first letter, and then C for case. Basically, these are just separate ways that you can break up multiple words if your object really has to be more than one word. You can also use a combination of both. So you could have both underscores and capital letters. I will say though, if you do use capital letters to break up words, do remember, as we just kind of talked about, R is case sensitive. So what that means is, you know, if you called your object cool data with a capital C and a capital D, you need to use that capital C and D every time. If you try to say, hey, R, like show me what's inside cool data with lowercase letters, it'll be like, that object doesn't exist. I tend to use underscores for a couple different reasons. First of all, more programming languages are cool with underscores than they are capital letters in object naming. There are certain other programming languages that will actually break if you try to use capitalization for object naming. The other reason why I like underscores is very much a personal one. I'm dyslexic, and it's actually kind of hard for me to see the difference between uppercase and lowercase anyway. And this is just like easier for me to read. So I will generally prefer underscores to break up my words if I have multiple words in a object name. Finally, this last one isn't not a rule, it's more of a guideline. But the idea is you want names to be unique and short but understandable. For instance, what you don't want to do is just be like data 1, data 2, data 3, data 4. By the time you've done like, 10 of those, you're not going to remember what the heck was in data 1 and what did I put in data 5 and what did I even do with data 10. So preferably not that. But you also don't want them to be so long that you're going to have to be like typing out this giant word collection of words every time. Because that's going to get really cumbersome in reading, and even be able to read your code. So sort of like, something that's short, sweet, unique, is sort of like what you want to get used to. Granted, I feel like this one takes a little bit of practice. All right, so those are sort of the general rules for naming an object. Any question on our object naming rules? Okay, so as I mentioned, once we've created an object, we can go ahead and print the data stored within it anytime by just typing the object's name again in the code block. Granted, if it's a really, really big object, you may break it if you do it like that. Okay, so I did want to just have us do a quick exercise to kind of get used to creating objects in R. So I have the first one done for you, but then we're gonna have you all do the next couple. So let's say I want to create an object called object 5. So I first write the name of the object I want to create, so object underscore 5. And then I'm going to put into that object or assign to that object the number 5. Then I'm also saying print that object. So if I run just this line of code and hit play without the second line there, I won't see anything printed out because I'm just saying save this object called object 5. And it does show up in my environment. So if you look in the right-hand side of our environment tab, I now have something that shows up. It's called object 5. It has the value 5. If I want to actually see that in my notebook though, I want to say like, show me what's inside object 5. That's what the second part of the command is, right? This is saying save it as an object. This is saying now show me this object in my notebook. So now I actually see, okay, inside object 5 is the number 5. Okay, any question on sort of the structure, right? Because you basically have to, you can kind of think of it in a little bit backwards because you basically have to like take a box, open it up, name it, and then put things inside the box, right? So you're basically making this space first. You name it, and then you can put whatever stuff you want in it. So it's always going to be in this direction. Name of a new object first, and then put stuff inside that object. Okay, any questions on that concept? If not, that means everybody is ready to do the next one. So what I'd like you to do is create an object called object 6, and set its value to the number 6. So see if you can go ahead and write that code chunk here and play it and get an object in your environment. When you've done this, go ahead and raise your hand. If you're stuck, put something in the chat. But if you've got it figured out, raise your hand so I can kind of see when everybody's hand's raised in there. We're more or less ready to go to the next thing. All right, y'all are really fast. Anybody have any questions before I do this one? Okay, so very similar to the previous structure, right? So we got to start with our name. In this case, we want to call it object 6. And you see, as I start typing here, it actually pops up a couple of suggestions for me. So for instance, it says there is an object already that's called object 5. So this purple means that it's an actual object. If it's blue, that means it's actually a function. It's saying like, ooh, there's already an object called object 5. Is that what you want? Also, there's a function called object.size or objects. Would you like to use any of those? Now, if I really, I wasn't trying to make a new one, I could click on it and it would autocomplete for me. But obviously, I'm going to actually make a new object called object 6. And then I'm going to assign to that object the number 6. If I want to also print the output in my notebook, I need to start typing, I need to type in the name of the object again. And you see here, what's cool is as I start typing, a new color shows up. So purple is usually for objects, blue is for functions, but then there's this yellow, and that's because it's basically like a promised object. Basically like it sees earlier in the code chunk, like, ooh, you used this word already, this name already. But you've not actually made it yet. So it doesn't exist yet, but I know that you want to make it exist. So it's basically like an object you are about to create. So if I click on that, it auto-completes for me and all is well in the world. So if I click play on this one, I should see that I now have another object here called object 6 and its value is 6. And it's printed here as well in my notebook. All right. So R understands that the word 5 is equivalent to the number 5 and the word 6 is equivalent to the number 6. So if I ask R, hey R, add object 5 plus object 6, even though I'm using words, it understands what I'm really saying is add whatever this value is to whatever this value is. So if I go ahead, like let's go ahead and have you do that. See if you can get R to add object 5 plus object 6 together. And hopefully, if you've done it right, you get the output, which is 11. So go ahead and do that. Raise your hand when you've got it. R also understands the mathematical symbols. So like if you want to add something, you just use plus. If you want to subtract something, you use the negative. If you want to multiply some things, you use the asterisk, and so on and so forth. All right, I see most people's hands up. Any questions before I go through this one? Okay, so if I just want to know the answer of what object 5 plus object 6 is, I can literally ask R, hey R, what's object 5 plus object 6? Right, and like I said, R knows that I'm not actually trying to add the words, I'm trying to add whatever they represent in numerical values are. And so I say, all right, what's object 5 plus object 6? It helpfully says 11. Now, nothing happens over here in my environment because I've not asked it to save anything. I just said, what is the answer, right? I've not assigned an object to this value at all. So what if instead we want to create a new object called output sum and assign to that whatever object 5 plus object 6 equals. So see if you can create a new object called output sum that will actually be object 5 plus object 6. So go ahead and do that. Raise your hand when you've got a new object called output sum that's going to be equal to 11. All right, any questions before we walk through this one? All right, so the rules say if I want to create an object, the first thing I have to do is give it its name. And in this case, we've already said we want the object called output sum, and then we're going to assign to that object 5 plus object 6. If I could type, that would be great. Nope. Excellent. Now, if I want to also print out whatever's going to end up being my output sum value, I can also go ahead and use the object name there one more time. Now, I will say if we were not trying to break this down like super into small steps, if you realize that you wanted to save this, you could just like write, output sum here and then rerun this code chunk, right? And then it would do what you want it to do. But obviously, like I said, we're trying to kind of break this down a little bit more. So if I click play on this, I should now see a new object called output sum, and its value is 11 because 5 and 6 is 11. And I also see that in my notebook here. All right, so that's sort of our very short exercise on just navigating like how you create objects and sort of the rules around whether you save something as an object or just see it printed out in your notebook. So hopefully these different tasks kind of illustrated those behaviors, but does anybody have any questions on object naming before we get to our real data? Okay. So now that we know what an object is, we can go ahead and make one for the 2023 YRBS CDC data. So the first thing is we want to create a useful name for the data object we're going to create. I'm just going to use YRBS, so the youth survey data. And we are going to use our assignment operator to then dump our data into this object. As I mentioned, we're using this reader, this SPSS reader, to help us stream that data set. So the first thing is where the data is, and that's at the CDC YRBS files 2023. And then the file itself is this .dat file. So that's the actual like data. And then the sort of like linker data, the SPSS linker data is a separate file. So you want to point to that as well. So this is the SPS name, and that's under CDC YRBS files 2023, but then this is going to be the like .sps. So basically you've got like the data, and then like the information in the columns from the data combined. So we should be able to click play on this. And we should have a new thing show up in our environment. So before it was just kind of values, right? Because it was like a single value in that object, so it wasn't really complicated. But now we have like columns and rows of information. We have this whole data table. So that's going to show up in the data tab. And we see here we've got the new data tab that has the YRBS object, and it has over 20,000 observations and 250 variables. So the observations, basically each row is going to be a student, and then the 250 variables, like each one of those columns is going to be a survey question. You can also view this like as a interactive spreadsheet. So if you kind of hover over the object box in kind of like the white space and you click on it, it'll actually open up this spreadsheet view. It actually runs a command called view for you. If you notice, like the console actually popped up because it's actually running a little piece of code for you that creates this spreadsheet view. So you've got the spreadsheet view here. You can actually scroll across and see all. You can also pop up to the very end here. So you can scroll across all of the columns. You can also scroll up and down to go through the rows. You can also use the filter option here. So for instance, if I just want female, it'll pull up just the female data. If I want to, let's find something a little more useful here. Here we go. If I have numeric data, I can sort of filter based on like a particular chunk of those numbers. I will say though, like nothing you do here in this spreadsheet view actually does anything with the data. None of it's saved. This is really meant to be like interactive exploration to kind of help you figure out like what things you need to code. But it doesn't actually like do anything that's savable here. So this is mostly meant to just kind of like help you explore and feel like a little more at home in this more like Excel spreadsheet kind of view. It does open a new tab. So we can go ahead and pop back over to our notebook tab. So again, if you want that spreadsheet view, just click anywhere on the name of the object and it'll automatically open up this spreadsheet view for you so you can kind of explore, double check things. I like to do this sometimes when I think there was a value that I thought was in there and it's not, or I'm just like not understanding like the range of something or whatever. Every once in a while I come here and I just like check my sanity and things. The other handy thing is, if you also notice there's like this little blue triangle on the left-hand side of the object name itself, if you click on that, it also does a drop down where it'll actually show you like every column name, which is every variable. So that's also really handy if you want to like grab any of the variable names at any time. All right, any questions on sort of like getting the data into R? If this was a different type of file, there are other ways that we would read it in. And on Wednesday, we will go over at least one other way of reading in data, if not a couple others if we have time. Okay, so there are a couple of different ways that we can explore this data set. So for instance, we can use the dim function to explore the dimensions, but I'm telling you about the dim function for the first time. So if you ever want to understand more about what a function does, you can always type ? and then the name of the function in like a code chunk and hit play, and it will actually fetch it in the help docs for you. If you noticed when I ran this, it actually popped open the help tab. And it opens up this documentation here. It says dim is a base R function. That means it's not in a specific package. It actually comes with R itself. And then it usually has like a big one sentence like description, right? This one here is saying, oh, it gives you the dimensions of an object. If it were a complicated function, it would give you like a big description. I mean, this one really only does one thing, so its description isn't super complicated, other than it retrieves or sets the dimensions of an object. It also shows you how you can use it. It'll show you if there are any other like options or arguments to use with the function. Again, this is a super straightforward one, so not necessarily a lot going on there. It'll also have these details on sort of like the real nitty-gritty, like how the code works in the background kind of thing. I really like at the bottom, there are these examples. These are honestly how I learned to code. I love examples at the bottom of a documentation because it literally gives you things that you could paste into R and see what happens. Like I could literally copy and paste, you know, this whole code chunk into R, and then see what it looks like, see what happens, and then like tweak a piece of it, run it again, see what happens. That's how I learn things. Again, as I mentioned, I'm dyslexic, so I'm not necessarily like super solid at reading things. I like to do things. But the nice thing about the documentation is you get both, right? You get both like detailed description, you can like really dig into it, or you can just like run this thing and see what happens. Now, if you didn't want to actually like type the code in, you could also like go over to the help yourself, type in dim and hit enter. And you'll pull up the help doc. So basically dim is an automated way to have it like go over to help and type that in for you. Either way you want to do it is fine. I just like to show both. All right, so now that we understand that the dim function basically will show us the dimensions of an object, we can say, all right, use the dim function on the YRBS object, right? Because we've got, well, technically we've got a couple of different objects here, although only one of them really has dimensions, but we have to specify which one we want to run this function on. And so like you always have like name of function, open parentheses, object you want to do the function on, maybe some comma options or not, and then close parentheses. So this open and close is basically what kind of keeps the unit of the function together. It's saying like all the things inside this parenthesis belong to like this function. And the reason for that being is you can actually run like multiple functions in a row. So the parentheses sort of like keeps everything like contained to one particular function. So if I run this command, I will get my dimensions of my YRBS object, which obviously, like I said, we also do see that here, but it could be nice to have it in the notebook, especially because, right, if we render this into an HTML doc, nobody that would open that in the HTML will get like this whole side panel. They'll only get the notebook. So it can be kind of nice to actually see these things like in the notebook. All right, any questions on that? I feel like I'm gonna sneeze, boy. Whew. Okay. We can also take a look at the names of all the columns, great. So we can also click over here and see the names of the columns. We can click over here and see the names of our columns. But again, it can be really handy to actually have our column names like in our notebook for lots of different reasons. And the function to actually like basically print column names or show column names is by using the call names function. Now, if you want to learn more about the call names function, again, we can go over to our handy dandy help tab and we can type in call names. And we see that it's actually sort of a twofer. There's they're kind of like partner or family, I don't know how you want to call it, functions. You can either do row names or column names. This is also a base R function. And basically it will retrieve or set the row or column names of a matrix like object, depending on which flavor you pick. And again, I like to scroll down and just kind of see like, okay, how can we use this function here? But let's see if you can go ahead and use the call names function on the YRBS dataset. It will print out a lot because there are 250 variables, but go ahead and see if you can print them by using the call names function on the YRBS data. So it should be very similarly structured. So function name, parentheses, object you want to do the function on. When you've got your call names in your notebook, go ahead and raise your hand. All right, excellent. Y'all are fast. Okay, any questions on column names before we go ahead and use it? Okay, so like I said, I'm gonna use the call names function, and all I need to do is specify which data set I'm using, and I'm gonna use the YRBS object here. And that's it. I'm not necessarily gonna use anything, I'm not gonna use any of the options or anything like that, because I literally just wanna see what the column names actually are. And you notice when I hover over it as well, it actually kind of shows me the breakdown of what that function should look like, right? It's like call names, X is usually your object, and then like here are the other options you can use with this function. If I click play, like I said, it's gonna be crazy long because it's literally gonna print out like all 250 column names. If we didn't wanna necessarily see like all of them, we could use the head function and basically wrap it around. So basically we're saying like, only show me the first couple of lines of this, and then it'll just show you like the first 6 lines. But we actually do want to print all of them. So we're gonna use call names, YRBS, yes, YRBS. But I don't want to scroll through all these because like it's 250 things to scroll through. So if you recall, I can actually tuck it into my window by hitting the little minimize button. So then I can just pop it in there and I don't have to scroll through the entire thing. But like I said, if I ever need to, I can refer back to it, open it up, see it all, you know, copy a particular name if I need to in my code chunk. Okay. As I mentioned, there's a lot of data, a lot of variables in this data set. There is ways of extracting the data using sort of like base R functionality, and that's by using square brackets. So for instance, if I want to find a, if I want to extract all the column values from the second row, I could do that by using brackets. So I would say YRBS and then square brackets. And so the first position is the row and the second position after the comma is the column. And if I want to basically extract everything from the second row, I would say 2, comma, and then nothing. Because what this means is on row 2, grab all columns, basically all across row 2. You can't like just put 2 and then nothing, because like I said, you gotta kind of think of it as like the first position is always the row, the second position is always the column. So this is saying everything in 2 across the entire set. So if I click play on this, it'll grab the entire row 2, right? All across the entire set. So we've got like 1 row, but 250 columns, because it's basically just taking that slice out. If on the flip side, I'm only interested in extracting the how old are you column. So the how old are you column, if we look over here to remind ourselves, is like the second column. So what I want to do is say, all right, give me the YRBS data set. And then this time we don't have anything in our first position because we want all the rows for column 2. Right? So we've now kind of flipped it from what we looked at before. So if I want everything in row 2, it's 2, comma, nothing. If I want everything in column 2, it's nothing, comma, 2. I'm using the head command here because basically, again, this would be like 20,000 values and I didn't want to print them all out. So it's just going to show us the first couple of lines of column 2. I did want to just point out, you can also call specific columns by using this $ symbol. So for instance, if I wanted to grab the how old are you column, I could say, give me everything in column 2 by using this extraction brackets, or I could also say, give me YRBS $ how old are you? So there's kind of like 2 ways to do this in base R. Granted, on Wednesday, we're going to show you an even easier way, in my humble opinion. You can also extract multiple columns at once using the colon symbol. So for instance, in this particular code chunk, I'm saying, give me all rows in columns 2 through 4. So that would be 2, 3, and 4. So if I click play on this one, you do in fact see, right, I've got all the rows. So I've got the 20,000 rows, but then I only have 3 columns. How old are you? What's your sex? And in what grade are you? So that's columns 2, 3, and 4. If the columns are not next to each other, you actually have to do something slightly more tricky. We would have to use the C function. So the C function, if we want to know more, right, we can always go over here. The C function is a base command, and it's basically just to combine values into a vector or list. So in this case, I would say, all right, from the YRBS data, all rows, and then the C command will basically combine this into a list. So I can say, and a list of columns 2 and 4. So if I click play on this, I'm just gonna get 2 columns, right? How old are you, which is columns 2, and what grade are you in, which is column 4. So it does get tricky if they're not next to each other, right? If they're next to each other, it's super easy. You can use the colon, but if they're not next to each other, you basically have to create like a little list. So that's what the C command does, is basically creating this list, and the list will say which number of columns that you want. Okay, any questions on using the brackets for extracting like subsets of information from our object? All right, so then now it's your turn. What if we're interested in just extracting how old the student in the second row is, right? So if we need to remind ourselves where our how old are you column is, we can always check that by going over here, or we can also open the little tab again to remind ourselves where the how old are you information is. And then we want the student in the second row. So see if you can use square brackets to pull the age of the student in the second row. And raise your hand if you've got it. Put something in the chat if you get stuck. One thing to note, right now, I am not saving any of these objects, right? All I'm doing is printing them. I'm saying, show me what's in, these columns, show me what's in these rows. If I actually wanted to save any of these things, I would need to say like, YRBS underscore, I don't know, sub, let's just say, right? Then that would save whatever this output is. But right now when I do this, oops, sorry, fat fingers, this just says show me what's in this subset. So keep that in mind. And you don't have to save it for this one. I'm just saying show me what is the age of the student in the second row. Okay, looks like I've got pretty much everybody, their hands raised. Any questions before I do this one? Okay, so if I do YRBS brackets and I want how old is the student, so how old are you is actually our second column, and I want the student in the second row, so it'd be 2, 2, right? And I can see that they are 15 years old. And like I said, you can always kind of sanity check, right? You can go back to your spreadsheet and you can kind of look, all right, in the second row here, in the second column here, we've got male of 15 years old. Huzzah! right? So like that's what this spreadsheet can be kind of useful for, to kind of just like double check when you're doing things. Okay. On the flip side, if we wanted to remove columns, we can also still use this subsetting. So if we are, like, let's say we're interested in removing the how old are you column, and we want to save this whole new thing in a new object because now we're like removing data, right? We're trying to subset our data into something that's more small and manageable because 250 variables is a lot. So maybe we're like, okay, we want to subset this data, save that data, and that's what we're going to do all our computation on. So I would create a new object called YRBS_sub for subset. I'm going to put into that the extraction of YRBS, and I want all rows, and I don't want, so I'm going to basically subtract column 2. So if I click play on this, I should now see a new object, which is YRBS sub. And I see here that it's actually missing a single variable, right? We used to have 250 variables, now we have 249. And originally the how old are you was like the second column, and we see here that it is no longer in the second column. Instead, our second column is now what is your sex, which used to be in the third column. So you can also subtract or extract out basically like things you don't want. So you can both pull the things you do want or subtract the things you don't in this method. All right, any question on like base R extraction methods? Okay. One other thing I wanted to mention is if you're interested in taking a closer look at the structure of your data, you can actually use the str function. And again, if we ever want to learn more about it, we can always go over here and we type in str, we see the str. And this is where we actually see, originally we also always saw like base, base, base. Here we see in our curly brackets utils. So the str function is actually in the utils package. And its role, or its function, is to compactly display the structure of an object. So if I say, hey, show me the structure of YRBS, it's going to be huge because, again, I printed out 250 variables here. But basically, it's going to say, yay, this object, YRBS, is a data frame. This data frame has over 2,000 observations and 250 variables. And then it's actually going to give you the column name for each column. It's going to tell you what type of data is in that column. And then it's going to print out like the first couple of values of that column. So this is like, again, a really great way to kind of just see overall, like what does this data look like? I use this often when I'm exploring a new data set that I've never seen before. But I do want to kind of talk a little bit about these classes. So next to each column is the data class. So data classes are basically sort of ways of defining what kind of data is present in each column. So if you notice in our data set, like most of them seem to be the CHR. We do have CHR, but then we do have one NUM, but mostly CHR. So what the heck is CHR? So CHR is actually short for character string. And what it means is literally like a bunch of words together, right? So 16 years old is a whole bunch of words together, which means a whole bunch of characters strung together, hence a character string, or Amanda or whatever. Then you have a data class called integer. These are only whole numbers, right? So if we had any columns that were like only whole numbers, they would show up as int. We did notice that we had a couple that were NUM, right? Down here for how tall are you, we had NUM. That's short for numeric. And these are numeric numbers, right? So they can be either whole numbers or they can be decimal numbers. So they can be fractions or whole numbers. Those are numeric. You can also have logicals. These would be like true or false. And then you can have something called factor. And basically these are specific variables that fall into a discrete category. So things like male and female. And I will say R is not necessarily great at like guessing factors off the bat. It mostly classifies things as character strings, and then you have to kind of go back and explicitly tell R that these are factors. If we ever want to like double check a specific variable, right? Like I guess you could scroll through this entire shebang. But like what if the thing you were the column you're looking for is like column number 150? You'd have to like scroll through all of this, and that would be kind of a mess. So you could also say, all right, show me the class in the YRBS object for column what is your sex. So if I click play on this, it'll be like, yay, the class for the what is your sex column is character. So that's a way you can kind of like double check. And the reason why this matters is I will say that different types of data classes have slightly different behaviors. So for instance, numeric data will only be able to be plotted a certain way. You can do statistics on like numeric data a certain way versus like factor kind of data, which you can plot like specific ways because they're, discrete versus continuous. So they'll behave differently. So it's always good to kind of double check. Like I said, R tries to guess your data classes ahead of time, but it's also not always right. So double checking your data class, like especially if you're like you tried to do some plot and you get an error, you're like, oh, that's really weird. It may be that R did not guess the class correctly. Another really great way to explore your data is to use the summary function. So the summary function is a base R function. Again, if we go over here and we type in summary, we can see summary is our base R function, and it gives you an object summary. It is, and I love this, it really is a generic function. It will always spit out the exact same results. It's basically going to like give you the min, max, quartile range of your data. So I would like you to see if you can use the summary function on the YRBS data in this code chunk here. When you've got the summary of your data, go ahead and raise your hand. If you were stuck, please pop something in the chat. All right, so I think I got everybody's hand raised. So let's go ahead and use the summary function on the YRBS object. So function, parentheses, object we want to do the function on, close parentheses. We click play, and we will see a summary of every column. Granted, if you wanted to see a summary for just a specific column, you would then do a $, and then you notice when I type $, it actually gives me like the names of all the columns, which is super handy. So if I was really interested in seeing the summary of just how tall you are, for instance, I could go ahead and click play on that, and it'll just give me the summary for just the how tall are you column. But if I click play on the entire summary, I'm gonna get 250 little summaries. Although you will notice here that the vast majority of them are actually not giving us a whole lot of information, and that's because they are character classes. And so summary is really kind of only works for numeric data. So if you get to the how tall are you column, you see you get the minimum value, the first quartile value, the median value, the mean value for both how tall are you and how much do you weigh. And then we kind of go back to just being like, hey, these are character class, and I can't count characters because they're letters and I don't know what to do with that. So summary is really only good for like numeric and integer data. It doesn't really work for character or factor data. So if you want to use something better for factor data, there is a function called count for that. Oh, why am I scrolling? This is terrible. Minimize. Whee! There we go. Excellent. So if we want to pick a better function that handles categories better, we could use the count function. But the count function brings me to the idea of the tidyverse. So that function actually lives in a whole collection of packages called the tidyverse. And the cool thing about the tidyverse is it's basically all these packages that are meant to like work together in harmony, and they sort of like fit all of the life cycles of like a data science project, right? So like everything from importing data to visualizing data to modeling data, there's like a package for each step of this process. And we'll talk a little bit more about this in more detail on Wednesday. But like I said, there's over 20 packages in the tidyverse, and then we've highlighted a couple of them here. So I've already installed the package, but I need us to actually turn on the package. Do we remember how we turn on a package? If you remember, go ahead and see if you can turn on your package, and then put your hand up if you've got it done. So again, we can go to the packages tab, type in the tidyverse, and we see right now we do not have our box checked. So there's a function that can help us turn on our package. So once you've got your package turned on, raise your hand. If you are stuck, let me know. If you need a refresher, you can always pop back up to the packages part of our outline, or there's also a hint in our packages tab on what that function is called. All right, so as I mentioned, packages are kind of like manuals, and manuals live in our library. So if we want to turn on a package, we would say, whoops, I can't type while I talk, library. And in this case, we are interested in the tidyverse. And actually, you see when I start typing library, it actually tells me an entire list of all of the packages that are already installed. Not turned on, but installed. So if I start typing tidyverse, I see there's one called tidyr, tidyselect, and we want the entire tidyverse. So if I click play on this, you may not see anything like show up, but if we all want to like make sure that we've done this, we should now see a check next to the tidyverse set of packages. And yes, we do. Huzzah! So now that the tidyverse collection is on, we can use the count function. So as I mentioned, the tidyverse is actually a whole bunch of different packages, one of them being the dplyr package, which we will be using a ton of on Wednesday. But here I at least want to highlight there's a really handy function called the count function. And so I can say, all right, count for me in the YRBS object the categories in the column, what is your sex? So if I click play on this, it will say, and that's kind of looks ugly, so I'm gonna pop that out, boop. So I see that in the what is your sex column, there is both female, male, and NA. And then the N, or basically the number of students that have answered with either one of these three selections. So you've got, just shy of 10,000 females, a little over 10,000 males, and 158 students that did not answer this question. So that's really handy that we can count, basically like this is a way of summarizing like categorical data. All right, any questions on the count function? I use the count function a lot. That and summary actually are my two favorites. Okay, excellent. Well, that brings me to the last thing that we want to do today to make sure that we are good to go for Wednesday. So So we basically like streamed this YRBS data into an object in R. But I will say the R objects are temporary. They're not technically things that are meant to like be stable. And oftentimes if you like close your project and go away, like they don't necessarily stay. And they're not really technically meant to. So if we want to actually like make sure that we can quickly grab our data for Wednesday, what we might want to do is actually just like write it into a file. So that way we can pull it from a file on Wednesday. So in order to write files, we will actually use a function that's actually a whole collection of functions. They're like the write underscore, and then this asterisk here basically means like a wildcard, because the end of the write will tell you what kind of file you're writing. So I'm going to go to write, and I'm just going to pick one so I can show you. So it's part of the readr package, and it's write underscore delim, but there's actually a whole bunch of flavors. So you can do write delim because you want to write out a delimited file, but you can also do write underscore CSV if you want to write a CSV file. There's another write CSV too, because one is like comma separated, the other is tab separated, if I remember right. You can also write an Excel CSV, Excel CSV 2. You can write a TSV, so that's tab separated. So basically, like, depending on what you write after this underscore will be the kind of file that you're gonna actually write out. So in order to use the write underscore CSV function, you go ahead and say, all right, write underscore CSV, and then you have to pick your object, right? Because you could make any of these objects into a file. We're gonna go ahead and pick our original raw data. So we're gonna say, I want my YRBS object to be written as a CSV file. I want that file to be called yrbs.csv. So once we click play on this, we should now see a file in our files folder called yrbs.csv. And so on Wednesday, we will actually go ahead and read that in and continue our hands-on activities then. And like I said, this is just kind of a way to make sure even if our objects end up dying, we can go ahead and pull that data really quickly again. But yeah, so that's all the things that we want to cover for today. Like I said, on Wednesday, we're going to do a lot more data manipulation with the dplyr package. Any questions on anything for today? Yes, I will try my very best to make sure that it is up before Wednesday, just in case anybody needs to review anything. Takes like a couple hours for Zoom to give me the recording. All right, any other R questions, program questions? If you don't have any questions, you are all set to go, and hopefully we'll see you all on Wednesday. Oh yes, good point. If you have any questions or you did want to work through this again before Wednesday and you get stuck, please join our Slack channel. You are welcome to ask if you are stuck in anything there, and hopefully one of us can help you out. Thank you all so much for showing up today. And have a good rest of your day. Or night, yes, good point. Or morning, wherever you are.
I did have a question.
Yeah, what's up?
I didn't know that we had a meeting on the 29th. I just had the invitation for like today and the rest of the, meetings. Are we gonna have, is that recording up already? I'm not sure if I missed something. I know
Yes.
you were going over the open source, so.
Yeah, so like the meeting we had on the 29th was mostly just like going over the concepts of like open source and FAIR. And that recording is available, and I believe it's up on our website, correct, Padma?
Yes, I can drop the link on chat.
Excellent.
Okay, awesome. Thank you so much.
Of course, yeah, no worries. All right, if nobody has any questions, then I think I will close us down. Ooh, actually, I'm gonna stop recording first. I always worry if I don't, it glitches out.